Well, looks like we can start. Welcome back, folks. We're nearly done with the Unit 5B, and so far our entire Chapter 5 on statistics has just been concept after concept, vocabulary term after vocabulary term. But once we get through this unit, we'll be computing some more stuff in Unit 5C, kind of returning to this same kind of things we've been doing in the course all along. But also, we'll get some ways through 5C, but the major thing we're going to be doing this week as well is tomorrow we're going to be reviewing for our exam 2. This will be our second review. So come armed with questions. You can ask just about anything. I'll be happy to help out. And we'll possibly be doing some targeted questions off the version 2 document as well to form our class review. Well, I think that's about it for the announcements. Any questions or comments at all, folks, to start us out? Okay, well, as far as the quizzes go as well, quiz number 7 is based off Unit 4D, so getting that done as soon as possible is really great review in and of itself. And if you fell behind on any of the prior quizzes, then try to get them done as soon as possible. I'll accept them for full credit. And again, that's possibly just studying any one of these problems once again. And if you're fully caught up on quizzes, it's a good idea just to review them. You can do the blank ones that you can see here, that blank quiz 7, just as extra practice to make sure you're on target for the concepts in these sections. But here's where we left off in Unit 5B. We got most of the way through this problem. We were looking through the definition of a confounding variable. The thought is a confounding variable is some variable that's not the variable of interest in a particular study. But if we don't take it into account and try to control for it, it can confuse or affect or influence in some way the variable that we're trying to measure. So in this particular problem down below, this was based on a time management seminar that presents a study showing that adults who eat breakfast at the same time every single morning report much lower overall life stress than those who eat at irregular times. Looks like the problem is about life stress, and we're told the seminar concludes that, don't know how that zero got there, the seminar concludes that the physical act of eating at a precise time must be responsible for chemically reducing stress hormones. So it seems like in this problem, the thing that they're trying to measure, the variable of interest, is stress hormones. So plural, we don't know exactly which ones that they're interested in. That's the variable of interest in this problem. They think it's this variable's influence that it's in fact reduced by eating breakfast at the exact same time every day. And because it's a time management seminar, they probably have all sort of strategies to make that happen, make that a reality for you some way, somehow. So they're possibly selling something at the same time. So we mentioned when we were looking into this, the overall question is, do we have any reason to question the study? And we said yes, for a lot of reasons. There's potentially many confounding variables. The variables listed in the chat was what the people in the study ate for breakfast could certainly introduce or take away stress hormones. For example, if an entire pot of really strong coffee is part of my breakfast, my stress hormones are probably going to go through the roof. So what they ate, where they ate, who they ate breakfast with are all big influencers. And there's probably other confounding variables that are still not accounted for in this problem. Anyone have another take on what could be influencing the main variable, stress hormones, but is a variable this study just doesn't seem to be mentioning whatsoever?
Not really addressing how they're gonna measure like where people start and how they finish, how they're testing whether or not their stress is lower.
You mean like the baseline stress, and then they have to eat breakfast at say 6 a.m. every day, and then their stress levels after? Is that what you mean by start and end?
Yes, like there's no clear definition as to how we're testing whether the stress levels are lower.
Yeah, exactly. They were just making a measurement and saying something affected that without going too far into it, saying what the baseline was. So yeah, absolutely agree. Let's say here, let me know if I capture the concept completely. There is no baseline measurement for the stress levels to compare with the supposed, I'll say supposedly, they said it was reduced, but reduced from where? That's a really great question. The supposedly reduced stress hormones from eating breakfast the same time every day. So yeah, that's absolutely a big problem there. And when you look into what they're saying here, responsible for reducing, this is getting even worse because this is language of saying a control. And here they're saying they did something and they have a cause and effect, but there cannot be any cause and effect unless there is a control in a real design experiment. So they're making a really, really huge claim here. And I feel like this is kind of what this is targeting. If there's no control, there's no statement of cause and effect. So let's put that in there as well, just to go along with the statement. With no control group, even though they didn't say cause and effect in what they wrote out here, they're implying it. They're saying eating breakfast at the same time is responsible for or is causing a reduction in stress hormones, but there's no experiment whatsoever. And we can say with no control group, they cannot make a claim of cause and effect. And they really are reaching for that. They're pretty much saying it directly without using words cause and effect in the language that's been written out here.
They also
And
have said like this could be a study of two adults. We don't have any idea how many are in the study. You know, they haven't set any of the parameters to really give us an idea.
yeah, so it said adults, but yeah, that could be plural. That's basically anecdotal data. So let's mention that here. Additionally, there is no information on the sample size. So lots going on with it already. Other questions so far?
Uh, not a question, but it doesn't also doesn't seem to take into account any like medications these adults may or may not be taking that affect appetite in the morning or late at night when they before they go to bed, kind of a thing.
Yeah, so once we're thinking about who was even in the study in the first place, yeah, a lot of things can affect their baseline stress levels at the same time. And that goes kind of along with what Echo's saying. Also, if people know that they're in a study, that alone can influence their stress. So just the fact that they're in the study already is influencing this variable. This is a really hard variable to measure. And let's add to that the individuals, medications they may be taking, as well as them knowing they are in a study also influences that variable of interest once again. So we're thinking along the lines of additional confounding variables. This also influences stress hormones. So again, this is a really, really bold statement they made. It's a statement of cause and effect. We don't even know who was in the study, if it was a real study at all, or the person who is the time management seminar, him and his buddy just tried this out. There's probably no experiment. We don't know what they ate for breakfast, where they ate it. They're making a claim of cause and effect. And again, this is just a really pretty easy study to tear apart, right? And at the same time, there's probably also a conflict of interest as well, because it's a time management seminar. They're probably trying to get you to do some time management things, maybe buy a product from them. And they're just saying, hey, there's this study. We're trying to emphasize a certain outcome of the study because it's favorable to our time management seminar in the very first place. Other thoughts you might have thought along these lines as well is eating breakfast at the same exact time they claim is somehow reducing stress hormones, but it could just be that people who are eating breakfast at the exact same time, they might happen to have extremely regular schedules, very, very steady jobs, just very relaxed home life, nothing crazy, no emergencies ever happens. Maybe those people really do have slightly less stress in their life, but that has nothing to do at all with the fact that they're eating breakfast at the same time. It's just that their life is not stressful and it allows for that in the first place. So there's, again, lots of thoughts you can put for every single one of these examples. Anyone had any other additional comments to share with this one? Echo says it doesn't mention what time they eat. It could be 3 a.m. according to the unknown parameters of the study. Yeah, absolutely. They just say eat breakfast at the same time, but that could be 6 a.m. That could be 11:50 a.m. or 3 a.m. like you mentioned. Let's throw that in there as well. There's also no mention what times of eating breakfast occurred in the study. And absolutely, that's certainly important, right? Because you can imagine if someone was going to test this out and you're part of the group in this and they decide, well, you're going to eat breakfast at 4 a.m. every day. I bet if I was in that group, my stress wouldn't be reduced. It would go up. That's kind of insane. And that would stress me out having to hear an alarm clock go off at 3:50 a.m. every single day.
I think you might have touched on this too, but just to come out and say, it doesn't mention like specifically what type of adults they were studying, because adults itself is just very broad. So like technically college students are adults, but they're still 18, like 20, very young and up and active and stuff, and have very busy lifestyles versus somebody in their 60s who's potentially retired.
Yeah, that's a good point. Yeah, if you're retired and you're just eating breakfast at the same time every day, because I mean, you get up at 8 a.m. every day, that's not really what's affecting the stress, it's what's going on in your life. So that's a good point. Let's put down here the type of adults. Say that's a really good comparison. For example, college students versus elderly people who are retired have very different baseline stress levels and eating breakfast at the same time, it has less of an impact on that stress. Just that type of adult seems to be, again, the major factor there, more than whether they're eating breakfast at the same time influencing their stress.
And
Well, that's
one
kind
more,
of a fun one. There's a lot of concepts. Yeah, go ahead.
one more to bounce off that one too, because this one relates to me specifically. It doesn't mention if these are single adults or adults with families that have kids that might still eat at the same time every day. But regardless of eating at the same time every day with kids, it's still gonna be stressful getting them out the door.
Right. So this is, let's add that to here. Moreover, single adults versus adults with families, including many children potentially, I'll say is a major factor for sure. And no time management seminar guru is going to tell us do this one thing differently. It's going to change our stress, because all of these big factors, again, for these people that could have been in the study, those are the major factors influencing stress. Those are the confounding variables that we'd be most interested in. And it seems like
Yeah, I think Michael's end kind of died on us.
So it's not just my computer.
Oh no, there he went. He's gone.
Okay,
Now
I
am I
always
the host?
check
I
my
don't like that.
internet.
I think I'm back. Sorry about that, folks. I was mid comment on something and then Zoom just completely minimized. It's windy out there, so I wonder if the internet provider here at ISU is struggling.
It's been struggling for a couple days, yeah. So
Let me see. It looks like we are still recording, so I'll double check that that video doesn't have any weird issues when I go to put it in the playlist, but sorry about that. I'm not completely sure what the last comment I was thinking about on this one. Probably something along the lines of the major idea what this one is, the massive amount of confounding variables that you can find. And that was a lot of creative looks and takes on this. There's major, major problems for this one. And also was meant to be a conclusion that just is completely overreaching, going in terms of cause and effect. If you really want to measure something along these lines with stress hormones, the idea is there has to be a design and control experiment. There should be some baseline measurement of those stress hormones, whatever they were. Seems like the variable itself wasn't defined well. And then even at that point, if you're going to run an experiment like these, you have to consider who is in the experiment, going along with the comments that Zach was mentioning on the types of adults in the first place. So there'd be lots of issues to try to make this study work out. And even if they did make it work out, they're probably going to find, well, to what we already know, eating breakfast at the same time had nothing to do with stress hormones in the very first place. It was just a time management seminar. So that was a conclusion that just seemed convenient to them potentially. But let's try out the next question then. So I think we're through with our major definitions through these notes. And again, all the questions are the same on every single example. Based on the information given, we're wondering if you have reason to question the results of the hypothetical study. As far as explaining your reasoning goes, whether you're doing this on a quiz or exam, you don't have to put down as much output as we're putting down here. Pretty much we're using these guidelines with an emphasis on 1 through 6. And anything you find there that makes a study become questionable would be for full credit. Let me make that just a little bit bigger. So we are looking into confounding variables, defining variables of interest. And for the next one, let's see what else we can find. Okay, so same question, and the context this time is just one sentence. Doesn't mean you can't find a lot of stuff, just means it's a fast context. It starts off by saying, a study by an oil industry lobbying group is designed to assess a new green energy spending plan. So it looks like something in politics. It's about an energy spending plan. And so they've got an oil industry lobbyist group designing this study. That seems about right. I mean, those would be the experts in energy, right?
I mean,
Well, anyone have any takes on that so far?
immediate bias.
Yeah, absolutely. The oil industry leading the charge on designing the study is already bad, but also this is a lobbying group. That's even worse. That
Another
means these
immediate
are
red
people.
flag. Yeah.
Yeah, exactly. These are people who are going to talk to congressmen and senators offering their expertise on energy, but also possibly making millions of dollars in campaign contributions at the same exact time. They're assessing a new energy spending plan, but green energy is in complete conflict with the oil industry. So lots of going wrong. Let's see what we can tie down amongst the 8 guidelines. I'm showing 7. Let me try again. Among the 8 guidelines that we see here, I would say probably the biggest one that stands out would be the source. The source of this study being an oil industry lobbying group assessing a green energy green energy plan is a major problem. That's a source on a bias, that's a potential source of bias from the very researchers themselves. And even if these people who design the study are really honest, hardworking scientists, by the fact that they work for the oil industry and are a lobbying group, that's a bias nonetheless, no matter how many PhDs they might happen to have. And yeah, great question. They don't even say how they're going to assess this, designed to assess a new green energy spending plan. Probably doesn't sound good by what this looks like so far. So let's first start off with, this is an oil industry lobbying group, and oil industry lobbying group is an immediate bias since the oil industry and a green energy competes directly with green energy, and so going back to this group right here, this group has not just a financial interest, they have a major financial interest that could potentially be in the billions of dollars. I'll just say has a major financial interest for, again, they're going to assess. So I'll just say the assessment to go in a certain way. And when we say certain way, we almost categorically just mean a way that would be favorable to the oil industry itself. They'll probably do a lot of things, wrap it around a lot of science, and then just say, hey, this green energy spending plan, it turns out it's just bad for ordinary Americans, something along those lines. They'll make that work somehow, some way, because if it's the oil industry, again, this is billions of dollars. I don't know if billions is even the right order of magnitude necessarily. So again, Echo mentioned, how are they assessing? That's another red flag. There is no indication how the assessment will happen. And Amy says, we also don't know if the sample group will be representative. There may be bias in the sample. And yeah, there's no information on what country, state, city the group is coming from. And when it says assess a new green energy spending plan, it's hard to know even what they're doing. What is the sample even going to consist of in the very first place? How are they going to make measurements? So yeah, let's put that down as well. There is no information on what the sample statistics are based off samples, computing statistics, estimating parameters, but we have no clue how that's even going to be done. Possibly just because, again, this context was really, really short, just one sentence, but that's fair game as well. No information on what the sample even will be and what country, going along with Echo's comment as well, state or city. If I think we're thinking in terms of the lobbyist group themselves, that the members of the lobbying group are from. But again, major red flag is once again, the oil industry lobbying group are assessing something that is competing directly with them. This is just a major bias in the source of the study, just right out of the gate. Other questions or other comments to go along with this one?
It also doesn't say how they designed the study either.
Yeah, there's really no information here. All they're saying is they're going to assess. We don't know what the sample is. We don't know who's doing the assessing. What is even the magnitude of this assessment is even going to look like. There's a new green energy spending plan. It sounds like that's something that might be passed by Congress. It's a proposal, but who knows on what criteria this assessment is even going to happen. I'll say kind of like that as a paraphrase. There is no criteria on how the spending plan will be assessed. Echo says it doesn't mention why they're qualified other than they're a lobbying group, right? I mean, they might go off to say this is all about energy, right? Whether it's green energy or other sources, it's all about energy uses, maybe in USA or globally. And so the oil industry will claim we're experts on energy use. We just happen to work for the oil industry, but that makes us somehow qualified. But we know that's shaky. That's a major bias. There's more to assessing energy, but than just being part of an industry and their lobbying group to boot. So let's put that here as well. There is no mention on how the members of the lobbying group is even qualified to assess energy. And I'll say here, green or otherwise. And again, this was something that was really very high stakes, maybe in the USA government as well. The oil industry, they're going to probably really put a bunch of PhD type people inside of this lobbying group just so that they can have the credentials just completely stacked. If they could look like they're the world's most important experts, the most knowledgeable people on existence. But we would know that they're also extremely well paid as well if they came from the oil industry in the first place. They're not independent whatsoever. So it doesn't even almost matter how much credentials they might have to qualify the energy span, because the major bias already as being part of the oil industry, assessing something that competes with them directly, kind of just nullifies however many credentials they might have even had in the very first place. Well, other questions or comments at the moment? I think this one was kind of fun because once again, it was just a one sentence one sentence context, but there's plenty you can say even about this one. Well, we have one last one to get through. And again, every problem that we've gone through here, we've kind of just torn it apart. In the actual homework exercise, I think there's either going to be one or two of them where the study was intended to be appropriate, that you had no reason to question. But even if you're doing those as my lab problems, I think I might have said WebAssign on accident. Even if you're doing them as my lab problems, you might come up with reasons to question the study, even if the problem is intended to go a certain way. So let's try this out again. This will be the last one for these notes. So same question as always on example 7. We're wondering if we have reasons to question the study. It says, dentists studying dental hygiene circulate a questionnaire to a simple random sample of middle school students in Pocatello, asking each student, did you neglect to floss your teeth this past week? Okay, so that's the whole study. You know, when I read this the very first time, I was thinking that dentists are going to be in the classroom with the middle school students directly asking them. That'd probably be really concerning, but it looks like it was on rereading. They sent out a questionnaire. So a whole bunch of students, a random sample, that's good, right? We have a random sample, but of just middle school students, that has narrowed our population to dental hygiene amongst middle schoolers in Pocatello only. So even if our population was meant to be broad of all adults, perhaps, it's been narrowed by the random sample they took. And they wrote out this survey question. Did you neglect to floss your teeth this past week? Will anyone see any problems with this study?
Yeah, they need to clearly define what neglecting flossing your teeth could mean. Middle school students may think that means you have to floss every day, or if you flossed once, you're good. We haven't clearly defined that.
That's a good point. So the variable of interest, we're looking at guideline 4. Ambiguity in the variables is on neglecting to floss your teeth or just flossing your teeth in the first place. So let's start with that one. The variable of, I guess I'll state it, neglecting to floss your teeth is not well defined. And the example, let's put in the examples you mentioned. For example, does this mean daily flossing? The dental hygienist probably had an intention, but we're talking to middle school students, so that has to be spelled out in the survey right here. So does this mean daily flossing versus once per week? And Echo also says all the kids are going to say they floss their teeth. And yeah, I'd absolutely agree with that, because this is a survey question that's written in a way that kind of makes you feel bad when you say neglect to floss your teeth. Middle schoolers know that they should. We put in the word neglect, so now there's a loaded emotional language tied in here. We're asking kids to admit that they did something bad, and if this is a questionnaire that's kind of open, everyone can see everyone else's answers, you might be embarrassed if you said, yeah, I didn't floss at all. That sounds like a personal hygiene failure. Again, middle schoolers are sensitive to that kind of thing, so it'd be embarrassing to say yes in the first place. And that's kind of going back to, let's see, the wording in the surveys is not great for this. They could have rephrased this better. How many times did you floss your teeth in the last 7 days? Something like that would have made a lot more sense. So going with what Echo said, the students are going to mostly, there might be a couple gold ones that say, no, I didn't, and they're just taking a stand on that. But they're probably mostly all going to say no to the survey question, implying they did floss out of shame. They know they're supposed to, or embarrassment. Because, I mean, this was a questionnaire that went to middle school students. There's a chance that if this went into, say, well, it did say a random sample of middle school students. My embarrassment here is me imagining that it just went into an entire classroom. That wouldn't have been a random sample. But if anything like that happened, if any of the students could compare answers, that's going to be really problematic as well. And Echo says, do you have to use string floss? A placker, water pick? Yeah, flossing is really very undefined here. There's lots of ways you can potentially floss. I like that comparison of water pick, placker. So let's put here. Flossing is not well defined because it could mean string, maybe wax string or otherwise, a placker, water pick. And I bet if you go amongst other cultures across the planet, there's other notions of what flossing can mean as well. Other strategies to get the same kind of effect on dental hygiene. So I'll just put here, etc. So number of times to floss a teeth is not well defined. Flossing itself isn't well defined. Survey question is just loaded with emotional language the moment they put in neglect. Loaded emotional language that could shame the people taking this questionnaire in the very first place. And to middle schooler, flossing is a dance. So yeah, there's lots of problems here in this entire problem. The dentist probably meant well. They want to go ahead. Sorry.
Oh, no, you're fine. I was going to say, I think the middle schoolers themselves are kind of a variable because it's a random questionnaire that's sent out. there's no guarantee that anybody's even going to answer it, especially in a group of middle school kids.
I wasn't thinking that at all. We have a simple random sample of middle school students. I think when I read this question the first time, my imagining was these kids are already in class and every student in the classroom is receiving a questionnaire and the teacher just says, hey, fill that out. But that's not the case, right? This is a simple random sample. They're not necessarily in the classroom at all. They might be at home. And that means there could be a participation bias. They have to do an entire questionnaire, and no middle schooler has time for that. Adults hardly have time for that. So yeah, I think that's a really great take on that. Somewhere down the line here, we have a particular kind of bias on participation bias. So I don't think selection bias is a major issue because they try to get a simple random sample of middle school students, but they may not fill out the questionnaire in the very first place. So participation bias occurs when people, now we're talking middle schoolers, and they can be kind of fickle. They get to choose whether they're going to participate or not. Dental hygienists, they may not get any responses whatsoever, maybe just a couple, a small handful. So it's put here because the students must participate by filling a questionnaire I'll just say sent to them. We don't know how they're going to receive it. Maybe it's in the mail or something. Sent to them. There will be major participation bias. And oftentimes when it comes to these, people who do participate have a really strong opinion, but maybe in this case, if it's dental hygiene sent to middle schoolers, the middle schoolers that did participate, maybe they were just bored and they had nothing better to do than fill out the questionnaire saying either yes or no to it. Yeah, so that all we know is we have a simple random sample. Let's put that in here as well. There's no information. On how the students received the questionnaire. It could be assembling outside the random sample range. Yeah, so if they're, say, mailing it to a house, some other kid might have responded to this and they may not have been in the attended sample whatsoever. So yeah, that goes with no information on how the students receive the questionnaire being problematic, since if since doesn't work there unless I say this is problematic first. This is problematic. Since if these were sent to a home, someone outside of the targeted age range may respond. They can make this study really expensive by sending the dentist or maybe just a whole team of researchers to every single home that's intended to be corresponding to a middle schooler in the simple random sample, and then just watch, make sure, check IDs or something along those lines. But even then, mistakes would happen potentially. So again, this is a pretty tricky study in a certain sense. My mental image of this was completely wrong, thinking an entire classroom was getting the questionnaire. But the fact that it's a simple random sample, that's good in a way, but then extra problematic at the same exact time. What they could have possibly done better is go make a listing of every single possible middle school in Pocatello. Then after they've done that, that's a good amount of middle schools, randomly select maybe 5 of them, then include every single middle schooler in those 5 schools, and then use the administration, the teachers to make sure every one of those students fills out the questionnaire. But now, even if you did that, which bias gets worse? Probably this one, because now students, there's no privacy really in that kind of situation. And if you're responding to something that might cause you to have some embarrassment or shame, the fact that your peers are all around you is going to influence this survey very, very heavily. So this study seems like it's going to be one of those things that it's really hard to get to do right. They should possibly just rethink it from the ground up. But anyone have any other takes about this that we've missed so far? Okay, well, we did it, folks. That's the second unit in chapter 5. This really goes along with what we were doing in the unit 5A, but putting all this in unit 5A, I guess would have made that one unit just a little bit too long. So again, the major takeaway is when we're doing this as either a quiz problem or exam problem, try to relate to anything that's going wrong amongst these 8 different guidelines with a focus on 1 through 6. Those are the ones we were really thinking about on each one of those examples. And if you are doing this as a quiz problem or exam problem, you can put down a lot of statements here, and that'd be just fine. But just one hard statement, if this is all you said, the very first bullet point, or maybe this just the second bullet point and so on, that'd be sufficient as well. Some people might have different takes. For example, this question right here was, let's see, further up, almost there. This question right here was meant to be the one where I was thinking, no, there's no reason to study this. It's a random sample done appropriately. But if you have a different take, that's just fine as well. Supports why you either said yes or you either said no. Thinking in terms of these various guidelines, use the context, and then you'll be always just fine. These are very subjective kind of questions. Well, we're going to turn into the next unit. Only just to get started, see what's going on in that new landscape. We'll be finishing off that next unit, 5C, when we come back after the exam on the 16th, directly a week away from today, since tomorrow we'll be just reviewing for exam 2. But still, let's take a look at what's going on in the next unit. Here, we're getting back to doing some computations with the goal of, let me open up unit 5A once again. Our major goal is to think once again about the overall process of a statistical study. It's broken down into 5 different parts according to how our author sliced it. We think about what our goal is, identify a population. Now we're imagining we have a sample, that part's already done. We have data that we're looking at. That's the context of unit 5C. We have collected the raw data, and we're focusing on this part. We're summarizing the data. Before we compute the statistics, we want to see what does the data look like. We want to create tables, create various graphs to represent the data. So this whole unit 5C is the descriptive statistics side before we actually calculate the sample statistics themselves. We're just describing the data in terms of tables and graphs. So we have some returns of different formulas we've seen throughout the notes. Relative frequency should feel very familiar to what we were looking into way back in, say, chapter 3, unit 3A. We're using these kind of ideas when we're writing out relative frequency. The only difference is when we're writing out relative frequency, we're losing the times 100% portion. Essentially, we're just going to be writing our percent as a decimal number. So here's our full set of definitions to start out. There's lots to think about, but really, it's not too bad to put all together. The idea is we have some statistical data. We want to represent it in either a table or a graph. And first thing we'll focus on are the tables themselves. We'll create a frequency table using these data that we see here, these random letters. The first column lists all the categories of the data. That'd be the letters rather, that comes up. The second column is going to be the frequency. How many times did each one of these letters actually occur in our data? Then we'll add a couple new columns. Relative frequency is essentially a percent, but we write it out in decimal form. And cumulative frequency is summing together categories until we get to a total. So that's the whole set of definitions. And again, definitions like these are kind of hard to put together until we just immediately consider it in the view of an example. So this will be our first example to create a table. And here's the context on example 1. We're told an astronomer is classifying a newly discovered cluster of exoplanets based on their primary composition. What kind of planets are they? The categories are gas giant, so that's what the G represents when it comes up. Neptunian, so like our planet Neptune. Super Earth, so a rocky planet, but much, much more massive than the actual Earth that we're on. And terrestrial would be a planet much like Earth. Maybe Mars, something along those lines. So an astronomer found a new cluster of exoplanets. They've identified these 4 different types. And what we're going to do is take all this data that's kind of hard to understand, but if we construct a frequency table, a relative frequency table, and then a cumulative frequency table, we'll have a better view of just what exactly is going on with these data. Well, that's the start on this one. Any questions or comments so far before we start constructing the table? Okay, let's give this a try. First, notice this data is kind of weird. These are all just categories. These were planets discovered, and they're either categorizing them as one of these 4 different kinds of variables. So we would call this data categorical data. If it was numbers, if they were, say, times, or maybe distances, anything along those lines, we would have called them quantitative data or numerical data. But here, this is purely categorical, much like, say, a collection of blood types. Or if we're going to build a frequency table, we're going to have 2 different kind of columns, a first column and a second column. So we're going to start there. They'll add 2 more columns just to look into these other definitions. First column lists all the categories. So we can give our categories a name. Let's call these primary composition. They're categorizing these based on their primary composition. So let's call that our categories. Primary composition. Now the categories that came up, they're listed in order here. I'll just maintain the same order that they came out. G for gas giant. Let's make this a little bit longer just so we can make sure we have as much space as needed. Next category in the context was N for Neptunian, then Super Earth, S for that category, and terrestrial T. So we have one column listing all the categories. The next column, here's where we have to be a little bit more careful. Second column lists frequency for each category. By that, we just mean the number of data values in the category. Or said differently, how many times did the category G come up? That would just be the frequency. And here's where the problem does get a little tedious when you're doing this in MyLab. Because we have to be really, really careful on our counts, if I make any mistake and lose a letter G, even if you have perfect knowledge on how this problem goes, we lose the question in my lab, making it frustrating. So this is one of those problems where slow is fast. Let's be really methodical. Here's 1, 2, 3, 4, 5, unless my eyes went cross-eyed and I missed any. Looks like 1, 2, 3, 5 gas giants were in this new cluster of exoplanets the astronomer discovered. Then once we've done that, we just do it all over again and go to the next category. And, anything you can do on paper that helps us out, say in an exam setting, is not a bad idea. So I'll put these markings here, imagining this is a pencil that I'm writing down an exam, just so that when we go to the next category, it's going to be easier to identify. So now we're looking into the number of Neptunian planets, and we are spotting 1, 2, 3, 4, looks like 5 again on this one. So 5 goes into that frequency. Let me double check. 1, 2, 3, 4, and 5. That looks about right. And then on we go down the line. Very different from like what we were doing in the last sections, right? The last sections were just pure context in both units 5A, 5B. Now we're taking data and trying to compose it into a nice table. We'll be looking to some other graphics later on. But as a different feel, this is just methodical, careful work this time. So now for Super Earth, I see 1, 2, 3, 4, 5, 6 altogether. Oh, 7. Don't miss that last one. And finally, we're looking into the terrestrial ones. So Earth-like planets. I'll leave these unscratched off. So we have 1, 2, 3 altogether. Because our eyes can be deceiving, there's another good strategy here. They didn't tell us how many observations there were, but let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, so that we have 20 observations. Or we could say n is 20 for a sample size. Now some of these, that's 10, 15, 20 altogether. That tells us we didn't miss anything unless I miscounted the data and then summed them wrong as well. But that's all that's going on so far when we say a frequency table. We say what are the categories according to the variable. How many times did each category come up? We just mean frequency. And now when we say relative frequency, this feels an awful lot like doing a percentage because we're dividing by a total. We're just not doing, once again, sorry, this part right here, multiplying by 100%. It's expected that when we do relative frequency, we're going to put these in as a decimal number. That would be mostly for my lab. If you did this as a quiz or exam problem and you just decided you wanted percentage, that's just a unit change, and that would be just fine for me. But we'll do it as if it was a MyLab question because they will complain. They want these as decimal numbers. Oh, sorry, that n down there was meant to be the size of the sample. So n equals, thanks for asking about that, the sample size. It's not a random sample. This is just everything they found in that newly discovered cluster of exoplanets. So they found 20 observations. And that's helpful to identify for another reasons. When we say n is 20, maybe a better thing we should have said is there's a total of 20 observations, because that's what's going to be used in that computation there for relative frequency. So we'll say as well, the total is 20 altogether. Other questions at the moment? Okay, let's put down our new column, relative frequency. Let me just make sure I don't use up all the horizontal space. Okay, so these data, they're really hard to understand when we just look at the raw output, all the different categories that they came up with. But you notice once we put it in a frequency table, we have a really good understanding of what they really discovered in their new cluster of exoplanets. They discovered about the same amount of gas giants, Newtonian, and super Earth planets, slightly more super Earth planets, and not as many terrestrial. We have a really great feel for the data. But we can turn this all around. If we think in terms of the total as 20, we can calculate relative frequency on every one of those categories, which is essentially a percent without the percent unit there. So let's compute this next. We have to do 4 computations, but they all look about the same. We take a frequency in the category, so that's the cell here on the left. That becomes the numerator, 5. We divide by the total, the number of observations, or just the total frequency right here, which is 20. And we could say 25% of the data were gas giants. If you again said 25% here, I'm okay with that. But for the sake of my lab, they want relative frequency this way. Just as a decimal number, 0.25. So frequency goes here, we divide by the total. And we just need to do it, 3 more times. Except if you have a 5 here again, it's the same exact relative frequency. No reason to redo it in the calculator. We can just put in another 0.25. Then next one, it's going to be 7 divided by 20. So we get 0.35 altogether. And last one, 3 divided by 20 is 0.15, or just 0.15 altogether. And I noticed instruction said round frequencies to 1 decimal place. So if we were following that to the letter, we would have put down approximately 0.3, approximately 0.3, approximately 0.4, and approximately 0.2. I'm kind of regretful that I said that. I think I copied this down because some of the exercises in my lab indicated some rounding for some less friendly looking numbers. And if we did round, we'd get 0.3 plus 0.3 for a 0.6. Here, this is now rounding up to a 0.1, or rather a 1.0, and we would get a 1.2 altogether, which is a little bit strange. The rounding here is what's making this go a little bit weird. Because these are percents written in decimal form, if we take all of our original relative frequencies, 0.25 plus 0.25 plus 0.35 plus 0.15, it should always equal exactly 1 or 100%. But if you round, say you're following the instructions to the letter like we had here, rounding can make these sum to something other than 1, just because of the massive round up we did on the very first 3 categories. Well, we did it, folks. That's our relative frequency. Any questions on putting these down on paper? Okay, last one, cumulative frequency. It's still a frequency, so we're not using these values right here. We're going to base our cumulative frequency off of this column, the frequency column. As far as cumulative frequency goes, it is absolutely dependent on how you set up your table. So when I go to grade these, I'm just going to go by how you set up your table. If you put these categories in differently, your cumulative frequency is now different, but I'll see that and I'll still give you full credit. In my lab, they actually print this part first, so everyone gets the same answer for the cumulative frequency column. And here's why it matters. How the order can change the cumulative frequency. The cumulative frequency of any category is the number of data values in that category and all preceding categories as well. So if we're right here on this cell, and we want cumulative frequency, it's the data values in this category, 5, plus all the preceding ones, except there's none, which means we would just have a 5 on that cell. Then when we do it on this one, let's go through the definition again. Cumulative frequency on this cell where the red dot is going to be the number of data values in the category. So that'd be this 5 right here. And all preceding categories means you add on this one. Or equivalently, you could just add on that one as well. So this would be 5 plus 5 for 10 on the next cumulative frequency. We're adding the cell on the left and every cell above it at the same exact time. Cumulative frequency is now telling us, well, half the observations were gas giants or Neptunian, sorry, that word left me for a moment, Neptunian type planets. Then we have to do it again to get the next cumulative frequency, where we are right here at this red dot. We have to take all the data values in that category. They're referring to the 7 when they say that part. So 7 plus all preceding categories. That would be the 5 plus 5. These are all the preceding categories. But we've already done 5 plus 5. We can just use that value. It's really just 7 plus the cell right above 10 for 17 altogether. Then we do it one more time, but there's always kind of a shortcut to this one. In the cumulative frequency column, much like if we did it round, we should always get 1 right here. But this column should always end on the total. So if there's 20 observations, we have to get exactly 20. But just for the sake of practicing the definition, let's see how it would go. We have to take the number of data values in that category once again. That would be 3. Then all preceding categories, that'd be adding all these together. But we've done that. We know it's 17, so we can use those two values. 3 plus 17 comes out as a 20. And that's exactly right, because that's the entire count for the total amount of observations, or the sample size said briefly. So in the cumulative frequency column, the last row is not the most informative thing ever. It's just saying that's all observations, the total of 20. The first couple rows are more interesting because you can see how things stack together, how they accumulate, and that's how it gets its name, cumulative frequency. Well, we looked at the data set, and if you're like me, this is like no information, just looking at a string of letters. Now we have a frequency way of looking at it, a relative frequency way of looking at the same data, essentially percents, and if it's ever useful, a cumulative way to look at the data at the same time. We'll look at doing this for categorical data, as well as different kinds of data, quantitative data, coming up next when we take a look at these notes again. Well, this is kind of the warm-up for this section. We did this part, creating the tables. We'll also look into creating graphs, and then saying stuff about the actual data itself based off the information we provide using the context. But any questions at all, folks, getting through that very first example? Okay, well, again, we're going to have to kind of park the statistics chapter for a little while. Next class, come armed with questions on exam 2. We'll be spending all of next class reviewing. Then Monday, we'll be getting through our second exam, and we'll revisit chapter 5 when we come back a week away from today. But have a great night, folks. I'll see you all tomorrow.